for students to try out. Y is equal to A B bar, C plus A bar B C bar plus A B C plus A B bar. First, you need to identify the number of variables. Try to bring the lifetimes, and then see at which point the Boolean identities might apply, right? So let's go ahead. Let's look at sum of product form and then SOP. So the SOP form contain the sum of sum of different terms, with each term being a product of more than one literal. So it can be obtained from the truth table directly by considering those input combinations that produce a logic 1 at the output. So considering the table sum of product, in order to illustrate or explain the SOP, for instance, we have a 3 variable truth table, right? ABC with output. So the output there is no any rule attached to the output. In other words, the output are just arbitrary values that was given. The idea is to illustrate the concept of SOP. Excuse me. So let's see how it works. So remember, we said in getting the SOP expression, you are going to consider those ones that have the output of 1, right, at the output. They has 1 at the output given the truth table, right? So let's see how that works. So if you are doing that, if you are going to get those ones with the output of 1, right? So these are all so what happens with the truth table? You are going to form the truth table based on the given all the possible input combinations. So let me use that to illustrate how that is achieved, or how that is being done with particular respect to SOP, right? So we have 3 variables in terms of so let me replicate the table to show to you how that was done actually. So for the 3 variables, we have that A, B, and then C. So again, in populating the table, you have 2 raised to the power of 3, so you end up with 8 possible combinations for the variables A, B, and C, right? So let's see how that can be done. So for the first value, you have 4 zeros rather, 4 zeros, and then 4 ones, right? So in decreasing order, so you have for B, you have 2 zeros, 2 ones, 2 zeros, 2 ones, right? So for the last variable, you have 0, you have 1, you have 0, you have 1, you have 0, you have 1, you have 0, then you have 1. So the output excuse me, the output is given to be 1 0 0 1 1 0 0 1 1 0 0 1 0 1 1 0 0 1 1 0 0 1 1 0 0 1 1 0. So the idea is to illustrate how you get or you derive the SOP expressions from the truth table, right? So the SOP expressions, in getting that, remember, and then in the considering the SOP expression, the value for 0 appears complemented and 1 appears uncomplemented, right? So let's see how we can achieve that considering the SOP that says 0 appears complemented and then 1 appears uncomplemented. So let's try to write all the possible combinations in terms of 0 appearing complemented and then 1 appearing uncomplemented, right? So if that should be the case, so here we have a bar, B bar, C bar, because we all have all zeros. And then in the second column we have A bar, B bar, C. In the third column we have A bar, A bar, B, and then C bar. In the fourth column we have A bar, B, C. In the fifth column we have A, B bar, C bar. In the sixth column we have A, B bar, C. In the seventh column we have A, we have excuse me, we have B, and then we have C bar. In the last column we have A, B, C. So you have all the possible combinations. So what we are saying now, if you want to bring out the expression for an OCP expression, you consider the output, those ones that have the output of 1. So we have it at this point, we have the output of 1 at this point, we have the output of 1 at this point, and we have the output of 1 at this point. So we are going to consider those ones. So starting with the first one, so we have excuse me, A bar, B bar, and then C what? C bar. So plus A bar, A bar, BC plus A B bar C plus A B A B C bar. So that's exactly what we have this point. A bar, B bar, C bar, which is this, and then the next one is this one's with the output of 1. The next one is A bar, B, C excuse me, and then the next one is A B bar, right, C, and then the last one is A B C bar. So let's move ahead. So the next subtopic in question is product of sum. So the product of sum expressions contains the product of different terms. It can be obtained from the truth table by considering those input combinations that produce a logic 0 at the output. We are going to see that shortly. But in the case of POS, only one at the input is complemented. So what we are trying to say, the POS in this case, 0 appears uncomplemented, but 1 appears complemented. So using the same truth table, let's see how you can derive the expressions for the POS, right? So let me clean this. I think I will need, okay, let me clean this column, the whole of this column, this, let me clean this as well, clean this This will also be cleaned so that we can have the POS. So what I need is the POS, trying to get the POS expression, the same truth table. So in this case now, let's form all the possible combinations, and then we'll put it in the POS form. Okay, so now we remember we said for POS 0 appears uncomplemented, 1 appears complemented. So in this case we are going to have A plus B plus what excuse me, plus C in bracket. So that's how you represent the POS. So in the second column you have A plus B plus C. Remember we said for POS 1 appears complemented, so there's going to be a bar here excuse me, all in bracket. So you have A plus B, because of the 1 we have bar, and then plus what, plus C, right? You close your bracket. So you have A plus B all bar plus C all bar. You close your bracket excuse me, A bar plus B plus C, right? You close your bracket. So you have A bar plus B plus C bar, because of the 1, then you close. Let's close our bracket here again. I have A, because of the 1 I have A bar plus what, B bar plus C. Again you close your bracket. Then in the last column you have A bar plus B bar plus excuse me, plus C bar. You close your bracket, right? So in forming the POS expression, we said you consider those ones that have the output of 0. So the ones that have the output of 0 is at this point, we have it at this point, we have it at this point, and then we have it at this point at this point. So so let's see. So we have A plus B plus C bar. You close bracket. You consider this, the second one, A plus B bar plus C. Excuse me. You also consider the third one, which is A bar plus B plus C, right? And then the last one is A bar plus sorry, this okay, Remember, we are considering those one with the output of 0, so the correct one is is this, right? With the output of 0, which is this. So we have this is okay, we have this is okay, we have this is okay, and then the last one excuse me, with the output of 0. So this is going to be A bar, B bar plus what? Plus C bar, right? And then you have it. So that's how you form the POS expression given the truth table, by considering those one with the output of 0. So let's go ahead. I think the next concept to look at is the standard forms of SOP and POS right? So let's see how that can be done. So we are looking at standard forms of SOP and then the POS. Let's go to the board and then show you how that is done. So basically, standard forms of SOP, standard form, of SOP. So let's begin with standard form of SOP, right? So for instance, given an expression, a Boolean expression, AB plus what? Plus BC plus excuse me, plus ABC. Now we can say this expression is not in its standard form. Why? Because now if you look at how many variables can we see in this given expression. Now if you look at this expression, we can see that there are 3 variables in terms of ABC, but in some of the terms, for instance, the first term, if you look at it, is AB, C is missing. In the second term, A is missing, right? So how you go about introducing the missing variables in terms of A in the first part, either A or A bar, sorry, C or C bar in the first term, or A or A bar in the second term, is what is referred to as standard form. So in standardizing an SOP, there are 2 rules involved in it, right? 2 rules to enable you, standardize an SOP. So the first one, you are using the Boolean identity A, plus A bar A plus A bar, right? That is equal to 1. So you apply the first Boolean identity, that, and then the second Boolean identity is A excuse me, A plus it's A into bracket B, A into bracket B plus C, right? So such that when you expand this, you are going to have A, B plus A, C, right? So let's see how that can be standardized. So let's try to standardize this expression right? So starting with the first part of it, so let's take it bit by bit, starting with the first instance, AB, right? So let's put the missing variables. So if you do that, you are going to have A excuse me, so AB. So in introducing C, which is missing, so we are going to have C plus C bar. So we have applied the first rule, which is this. So it just to expand using the second rule, right? So if you expand, you are going to have A A B C plus A B C prime. Right, so that's it for the literal AB. So the second literal is BC, where A is missing. So let's see how you can introduce the missing variable A using the the SOP rules. So in this case, we are going to have B C. So let's introduce the missing variable in terms of A plus A excuse me, A what? A bar. So we have applied the rule 1. So it's just to the next is to apply the rule 2 by expanding. So expanding and rearranging, we have A B C. Similarly, expand and rearrange, you have A bar B C. So putting everything together, you have, remember, A B has given birth to, or it has produced two outputs, which is A B C plus A B C bar. That's for the A first part of it, AB. So for BC, it has also given produced the output, two outputs. So we have A, talking about this now, AB C plus what? A bar B C, and don't also forget to put the last part of it, which is this A B C. Now if you look at the final expression, you will notice that ABC is appears 1, appears 2, and also appears 3. So based on the Boolean laws, remember we said X plus X, right, is equal to what? X, so that you can reduce the number of repeated times. So based on those based on that Boolean identity, so we are going to maintain just A B C, right? Just we'll just pick one of it and then continue. So we have A B. So you also check if there's any term that repeated more than once, so you just pick one of it, so that you can have unique values. The reason is because, as we are going to see in K-map, if you are simplifying using K-map, you need those uniqueness to enable you simplify Boolean expressions. So we have this is also unique. A bar B C is also unique. So you see the way this has been standardized, right? So that's it for SOP. So let's quickly look at that of POS, right? So I'm going to clean this for now. Okay, so let me clean this. Let me clean this and this as well. So the next one we are going to look at is the standard form of what? POS, right? Standard form of POS. So the rule now, what are the rules to enable you standardize a given expression for POS? Is the following Boolean identities are used to standardize excuse me, to standardize the product of sum term, right? So the first one has to do with a dot a bar, right, is equal to what? Excuse me, is equals to 0. And then the second one is a plus bc. So if you expand this, it's based on one of those Boolean identities. You can check that out. If you expand this, you are going to have a plus b, right? So in the contents of product of sum, open bracket and close, so a plus what? Plus c, right? So based on these rules, we should be able to standardize a given POS expression. So let's see, given this, a plus b, close your bracket, and then we have b plus c, right? And then we also have a plus b plus c. So given this, so let's see how we can standardize that using the POS rules. So beginning with the first part, of course there are 3 variables. So in the first instance, c is missing, so let's see how we can introduce the missing variable in terms of c. In the second part, a is missing, while in the third part we have complete term, right? So starting with ab, so starting with ab, so ab, which is a plus b, this excuse me. So let's see, so we can have that a plus a plus b, right? A plus b plus what? Plus c. Remember, we're introducing c now, so c dot c, right? So we have applied rule 1. The next thing is to apply rule 2, which is this, by expanding that. So if you do that, you are going to have a plus b, right, plus what? Plus c, close your bracket, open and close. Then you have the second part. You have the second part, a plus b plus what? C bar. So that's it for the a plus b. So the next one is b plus c, where we are going to introduce the missing variable a, right, using the rules. So the same thing, you rewrite that, excuse me, b plus c plus what? Plus what you are introducing, a dot a bar. So same thing, we have applied rule 1, so the next thing is to apply rule 2. So if you do that and rearranging in terms of alphabetical order, so we are going to have that word a plus b plus what? C. Open and close your bracket. Then the next one is going to be what? A bar plus B plus C, right? So we've taken care of A plus B, we've taken care of B plus C by introducing the missing variable. So if you collate everything together, we are going to have A, right, plus excuse me, A plus B plus C, right? Open and close your brackets. A plus B plus C bar, right? B plus C, it has given the output of A plus B plus C, close your bracket. You have A excuse me, bar plus B plus C. Don't also forget to put the last part of the question, A plus B plus C, right? So again, you will notice that we have A plus B appearing here, A plus B appearing the second time, A plus B appearing the third time, right? So remember we said X dot X is equal to what? X. So you just pick one of those instances. So if that is done, so we are just going with A, we maintain just that. So A plus B plus C, open and close your bracket. Again, so let's see, A plus B plus C bar, so it's unique, so we'll maintain this. A plus B plus C bar excuse me excuse me. Again, A bar plus B plus C is also unique, right? So that's how you go about you know, the standardization of both SOP and POS, right? So let's see. So with this we have come to the end of this week's class. With we have some assignment questions for you to actually try. The first one has to do with using truth table, prove the following identities. We are given x into bracket y plus z. Try to show that is equal to xy plus xz. And then question number okay, there are two. In question 1 is x plus x prime y is equal to or equivalent to x plus y. And then the assignment question 2 is, why do we need to standardize an SOP or POS expression? So please try that out and then we'll continue in the next class. So that will be in week 3. Thank you and have a great week.